Edward from Edward Woodcrafting. I am presenting a series of videos documenting my project on supersizing my Onefinity CNC machine. This is part 3, the CNC router lift design. In part 2, I talked about a twist on standard toolpath tiling I called offset tiling and how it can reduce the amount of space required. And this, as I will explain, is key to my whole build. The space between the y-axis rails is about 20 inches, which means my plan on working on 24-inch wide boards won't fit with the standard Onefinity setup. So I needed to figure out a way to lift the entire CNC machine up out of the way of the larger boards. No easy task. The first thing I did was develop a 3D CAD model of the Onefinity machinist in SketchUp. Onefinity published a dimensional drawing, so I was able to scale my model pretty closely. It's not perfect, but it's well good enough for what I need. The Onefinity CNC design is, I suppose, an open rail type design. It's not supplied with any type of base. It's up to the owner to mount it on a table or a material sheet. The benefit of this design, well, I suppose it reduces costs since Onefinity doesn't have to supply a base for the unit. Usually it's aluminum or some other base. Second benefit is it's relatively straightforward to disassemble it, move it to another location, reassemble it in a relatively short amount of time. When I look at it, I see that it's supported by the 4 feet on the corners, and it's open front to back. As I mentioned, left to right, there is a problem with hitting the rails. But, you know, I looked at it and I said, I think you can lift the whole machine up by its 4 feet, to give me clearance to do my machine tiling on bigger boards. Now, when you set up the Onefinity CNC machine, then one of the critical setups is making sure that the Y rails are exactly in parallel. And you do that by sliding the X rail assembly to the back, screwing down that, moving up to the front, and the distance in the X rails forces the parallel in between the Y rails. So it's not a difficult thing to do, but it's very important. Otherwise, the machine would bind up. Now, if I want to lift up the CNC, it's kind of important to make sure that this alignment doesn't get messed up. So the question is, how am I going to do it? Well, let me state that I'm not a mechanical engineer, I'm an electrical engineer with just enough knowledge of mechanical things to be dangerous. But I do have a good analytical mind and some common sense. So I think I'm able to work things out and have a gut feel of how things will perform. You mechanical engineer types are free to throw some shade at me, but I'm going to lay out my thoughts and how I'm going to accomplish my goals. So rather than mounting the machine on a sheet of material, I'm going to mount it on a rigid metal frame, made probably of angle iron, although I'm thinking aluminum might be sufficient for the weight. The feet are 4 inches wide, so I'll need an angle metal of 4 inches on the bottom to accommodate the feet, plus a little extra slop room for the alignment to parallelize the rails. And I'm planning on having some cross members to make sure that once the machine is lined up, the rail system itself will stay in parallel, stay in without racking or twisting. The weight of the machinist, not counting the spindle, is about 80 pounds for the rails. And if you count in the spindle and maybe a laser module or whatever, I'm going to round it up to 100 pounds. And that would make 25 pounds on each corner and 50 pounds on each rail or beam. So I searched for a beam analysis calculator and found one that I could put in my information. My beam is a L beam type, 4 inches wide. I'm going to go with 2 inches high, 1/4 inch material, steel. So you can plug that in, and I'm going to use worst case analysis of saying the beam is a beam supported on 2 ends, or I should say attached to 2 ends. And we can calculate the moment of inertia from the material and the structure of the beam. And we come up with a calculation of a deflection worst case of less than a mil, thousandths of an inch. So I really think that's not a problem. I can't imagine this is going to be an issue. That's why I was thinking probably use aluminum, because it really is sort of a distributed weight and not a single 50-pound weight on the beam. So deflection would probably be even less. So as far as the mechanical structure, I don't have a problem. My bigger concern is racking or twisting of the frame, throwing the alignment out of whack. And so my latest thinking on that is, instead of just a plain cross member, is fabricate some kind of a U-bracket that can support the angle and keep the alignment in place. So just how am I going to lift the frame up off the board? I started off thinking I would build a really cool frame out of 80/20 aluminum excursions. I never worked with 80/20 before, so I started looking around, hacking, trying to figure out which pieces fit together, how much deflection, blah, blah, blah. And call my mad scientist version of my Onefinity CNC lift thingamabob. Probably had a few $100s worth of 80/20 extrusions in the build, and it looked like it was probably going to be a crazy build. But I'll present it. But don't laugh too much, because it just was a moment. I'm not going to get into too much detail of this idea, because I'm not going to do it. But the basic idea is there's an internal frame that's attached to our lift frame of angle iron, and there's an outer frame that pulls up that mechanism and tries to keep everything in parallel and locked in. And I ended up spending more time than I want to admit tweaking things and trying to figure out how to make it all work. And I kind of got it all working, and I thought I had something really cool. I spent one night working real late in the morning, tweaking it, testing it out, at least on the animations, and I went to bed. But then I woke up in the middle of the night saying, "Are you insane?" Don't let my wife answer that question. But if I learned one thing in engineering, it was a quote from Einstein: "Make everything as simple as possible, but not simpler." And clearly, my mad scientist version would not win Albert's approval. My midnight epiphany made me realize that the lift rails are really all I needed. That and a simpler way of lifting them. I recalled the design of a wood planer and how it lifts the cutting heads while keeping it parallel to the bed. I had to take mine apart one time and do some service on it. Um, but the concept is exactly what the same, is that you lift up the head of the planer by turning some lead screws that are connected together with belts or gears, turns in sync, and it lifts it up in parallel. And so that's exactly the concept. And without further ado, I present my idea for my simple CNC router lift. There are 4 threaded rods in each corner, and the rods are linked together by pulleys and a belt. And you can turn any of the knobs, lift the machine up, place it back down. The front of the machine is wide open, so you can have access for zeroing your machine or whatever you need to do. The rods are seated in a bronze flange bearing, and it's held up with a locking collar to keep it from sinking in. And it's the bronze flanges recessed into the baseboard. I also have the bronze bearing, probably for the guide pin placement, to keep everything, like I said, to keep everything from moving, especially when the frame is down. If you want to take a look at the model yourself, in a little closer detail, I put it up online. I'll put a link in the description. It'll open up on your browser, and you could take a 3D view of my design. When I put my order in for the machinist, I had 3 overall goals that I wanted to be able to do with the machine. Number 1 was to be able to work on larger projects, 24 inches by 24 inches. I think I can check that item off as a complete can do. Number 2 was I'd like to be able to set up the machine to mill dovetails and box joinery. I make a lot of boxes, and I think that would be a big help for me. And the final, not so much a big deal, but kind of maybe it's an idea to be able to transport it relatively easily, set it up on another surface like a dining room table, and do some engraving. The basic machine, that's doable. You just take it apart and reassemble it. But I think with my frame idea, it's a little bit easier to do, I think. It's still pretty heavy, so you might need 2 people to do it, but can be done. So I'm going to call that a check. So now we're down to number 2. How do I configure the machine to do dovetails and box joints? It's actually quite easy to reconfigure the CNC lift to work on dovetail joinery. Because it sits on a vertical rails frame, it's also possible to shift forward to the edge of a base or tabletop. Have a jig placed there to hold your stock vertically, and reconfigure the CNC lift frame, and you're in business cut joinery. You'll only be able to cut about 18-inch wide boards, but most commercial jigs can only do 12-inch boards. I make a lot of boxes, so this feature will be awesome for me. I'm really happy with my design so far, but the skeptical side of me does have a few concerns. The first being milling forces causing shifts and errors. By that I mean is as you're milling out pieces, if the CNC is not connected to the base well enough, then it could slide as the router moves around. This would cause lots of errors and not a good thing. So aside from the lead screws, which are half-inch lead screws into the flanges, I'm not sure exactly if there's any slop in that, so I'm planning on having guide pins on all 4 corners along with the lead screws to locate and keep the CNC frame from shifting. Now, my gut tells me when the machine is down, especially sitting on the base, I think it'd be about as good as the normal method of screwing in the feet into the base. When it's lifted up, I'm thinking it could shift a little. It's all a matter of compromise. So, I wouldn't want to shift it up any more than I have to clear the board I'm working on. So it's probably about 1.5 inches, 1 3/4. And I might have to adjust the feed rates, but I have to experiment on this when I finally get the machine. Another concern is Z-axis droop. In the lift position, the rails and the linear nuts are holding up the frame. And it's important that Z height does not shift during machining. Now, I don't think it's going to slip, but I'm thinking what I'm going to do is put some aluminum blocks at the height I need, slip it under the lift frame in the front and rear of the machine, and this would hold the height perfectly. And when you back off on the lead screws, it'll be very stable. So this will greatly help with my concerns for milling forces as well, because it should hold everything more stable. Also, I need to be concerned with trimming errors being introduced with the lift mechanism. Trimming errors happen when the router is not perfectly perpendicular to the milling surface. Normally this can be adjusted by tilting the Z-axis plate to reduce these errors. But when we lift the frame, I'm going to introduce some errors due to the slight differences of the lifting lead screws. But I think the best solution again is using my lift blocks, which if milled accurately, should place the frame in about the same level position as in the full down position. Okay, summary of the project. What did I forget? Is this idea awesome or crazy? So in theory, my project design seems to meet all my goals and seems very doable and relatively inexpensive. So that's good. I think it's scalable to the woodworker CNC owners, especially ideas of using a dovetail configuration, which I know people have asked about. But I would love any feedback on my project ideas, good and bad. And so, what's next? Well, what's next is I need to figure out my wasteboard configurations. I'm going to set up the indexing for my tiling of pieces. I need to think about an enclosure. I know it'll all fit into an enclosure, but what kind am I going to do? I'm looking around what other people have done. I got to worry about soundproofing, dust control, lighting, access. My idea is basically open front, maybe remove the top section held down by magnets, so I have full access to the insides. And that's about it. As I mentioned, the next phase is going to be finishing up these little details, start sourcing out the parts I'm going to need to do the build. I'm not going to assemble the unit until I have the CNC to make sure everything fits properly, and I will probably use the CNC to mill out some of the parts. But I thank you for listening, and I look forward to our next meeting. This is Edward from Edward Woodcrafting.